Okay, welcome back, everyone. So this is going to be the lecture number 3, I believe is what it is. Um, Before we jump into today's topic, which is going to be composite functions, let's go ahead and work out the homework. Number 1 was not starred, but I'm going to go ahead and work it out anyways, just because it won't take too long. So if I had f of x is equal to x minus 4, what would f of 3 give me? That's a 3, I promise. There we go. Well, f of x is x minus 4. F of 3 would be 3 minus 4, which would give us a negative 1. And then the next part was f of negative 2. Well, again, I have my f of x is x minus 4. And so that would mean f of negative 2 would be negative 2 minus 4, which would give me a negative 6. Alrighty. Hopefully that went well. We're going to be doing a lot of these substitutions today, so you'll get lots of practice. The second one this one was starred for grading. F of x is equal to 3x plus 1. Okay. With that definition in mind, what would f of 1 equal? Well, all I do is I replace the x on the right with whatever is in here, because this x is how I'm defining the function f of x, and I'm defining it as 3x plus 1. So f of 1 would be 3 times 1 plus 1, which would give us, let me erase that little tip there at the bottom, 3 times 1 is 3, plus 1 is 4. Okay? Next, let's do f of negative 2. Well, it's going to follow the exact same pattern. It's going to be 3 times negative 2 plus 1. And that's going to give me negative 6 plus 1 would be negative 5. All right? All right, hopefully that went well. And we can move on to the next one. So this one was a little tricky. We had f of x. I'm in trouble with my f's tonight. That's weird. F of x is x squared minus 4. Alrighty. What would f of 0 be? Well, again, f of x is x squared minus 4, so f of 0 would be 0 squared minus 4. 0 squared is 0. Minus 4 would be negative 4. Okay? And finally, f of 3 would be what? Well, it would be 3 squared minus 4. 3 squared is 9. Minus 4 would give me 5. And there you go. That is all the little substitutions for the f notation. Now let's move to the fourth one. In this one, we're supposed to classify the given functions as either even, odd, or neither. Okay? And so we start with, for part A, x squared plus 2. Okay? The only thing we look at when we're trying to tell if a function is even, odd, or neither is we look at the exponents for the variables. So this one is a 2, so that's definitely even, but then we seem to be missing an exponent over here because there's no variable listed. That's because the variable is hiding. If it's not listed, it is the variable x to the 0 power, because anything to the 0 is equal to 1. So 2 times 1 is still 2, so adding this x to the 0 doesn't actually change the value. So I've got a 2 and a 0 for my exponents. Both of those are even, so since all of the terms have an even exponent, it is an even function. Okay? Now for part B, we have, let's see, x cubed plus 5x squared. X cubed plus 5x squared. Okay. This one, the exponents, which is all we care about. We do not care about the numbers in front of the variable, just the exponent. So this one has an odd exponent. This one has an even exponent. And when you have a combination of even and odd, you wind up with it not having either symmetry. So neither. That makes sense? Alrighty. Hopefully so. The next one we had 2x cubed minus 7x. So 2x cubed minus 7x. And so this one is definitely odd. It's a 3. But this one doesn't seem to have one until we remember that if you have a variable and it doesn't have the exponent listed, it is to the first power. So that one is also odd. We have a 3 and a 1. Both of them are odd. Since all the terms have odd exponents, the overall function is odd. Alrighty. And last but not least, part D. We had 9x to the 4th, 9x to the 4th, plus 3. Okay? So, we look at the exponents. This one is even, and this one was like the very first one. It's missing the variable completely, which means the only way that happens is if you have to the 0 power, and 0 is even as well. So even though this number in front is odd, this number in front is odd, it doesn't matter. The only thing it tells you whether a function is even or odd is the power for the variables, the exponent of the variables. Even, all the terms are even, therefore it is even. And if we graphed it out, I guarantee you would have symmetry across the axis, which is kind of cool. Alrighty. Hopefully that went well. This tends to trip people up. The main thing is you do not look at the number in front of your variable. You only look at the exponents. If the exponent is completely missing, like it was here and here, it is x to the 0. If it's there, if it's just an x, but it doesn't have anything listed for the exponent, then that exponent is a 1. So if the variable's missing, it's x to the 0. If the variable's there but doesn't have a power listed, it's to the first power. And that's it. All right, let me clear the screen and let's dig into the next lesson. So here we go. Okay, so let's ease into composite functions. We're going to start off doing the F notation that we were doing, and we're going to beat this into the ground because that is the easiest way to get a good handle on composite functions. So we're going to start off with f of x is equal to maybe x minus 4. Okay, so one of the ways you can think of when you're solving a F notation problem, one of the ways you can think of the variable is it's just holding a box, and I can put anything into that box. F of x is x minus 4. F of box would just be box minus 4. And really that's all the variable is. It holds some value. It's a box that holds a value. So with that in mind, I can think about kind of plugging things into the box. So f of 3 would be, well, imagine I put a 3 into this box. Well, then the 3 would be over in that box. So I would get 3 minus 4, which is negative 1. Okay? If you don't like the box, you don't have to use it. It's just some people find it to be a nice way of thinking about the variable. Because if I make my box, instead of an x, I make it a box, like that, it's really obvious when I plug in a value. So f of, I don't know, 16 would equal, well, put 16 into this box. I then put 16 into that box, and I'll wind up with 16 minus 4, which will give me 12. Okay? You do not have to use the box, but some people like it. It's all good either way. Now, if f of x is x minus 4, let's not use the box. Let's go f of negative 5. So f of negative 5 would be negative 5 minus 4, which is negative 9. Okay, let's keep the same definition. F of x is equal to x minus 4. Alrighty. What would f of a smiley face be? That's a really terrible looking smiley face. My goodness, that's nightmare fuel. Alright, that's okay. So f of x is x minus 4. F of smiley face would be smiley face minus 4. Okay, what about f of, triangle? Well, f of triangle would be triangle minus 4. That's just a straight substitution. If f of x is x minus 4, f of triangle is triangle minus 4. Alrighty? Now, what if I put a big old rectangle over here? Nice long rectangle. What would that give me? Well, it would be nice long rectangle minus 4. Right? Okay? And I'll clean that up just a little bit. There we go. So, now, what if I put something larger into the big rectangle here? What if I put 2x plus 1 in? Well, if I think of it as just a container, I can then plug in 2x plus 1, 2x plus 1, and I'm going to wind up with 2x plus 1 quantity minus 4. And you can leave it just like that. Okay? So, if you think of your variable, your x here, as holding, it's just a box or a container that holds a value, and it's equal to that same box minus 4, then you can start throwing things into the box and getting it to sort of make sense. So I can put anything I want in this notation, and it will just distribute down. What about f of maybe 7x squared plus 5? Well, that would be 7x squared plus 5 quantity minus 4. Do you see where how this is working, the pattern behind it? It may feel like I'm just beating the horse into the ground, but this is one of the areas that students tend to have a lot of problems for it to click. And once it clicks, you can't unsee it. It will be there forever for you, and life will be wonderful. But you have to get it to click, because these type of problems where you're using the F notation to plug in more complicated things tend to either go really, really positively or really horribly on the exam. So here we go. Let's get nice and solid with this. Let me clear the screen and let's try a few more. So I'm going to clear this. I said I'd clear it. There we go. Now, I'm going to try something a little bit different. Now let's do, and you'll have to bear with me as I'm going to kind of do this kind of rapidly. So here we go. F of, let's say, x, nice blue, equals x plus 5. Okay? So now I'm going to use color instead of drawing those boxes and everything. Alrighty? So if f of x is x plus 5, what is f of 3 give us? Well, that just gives us 3 plus 5. Okay, what about f of negative 7? Well, that would be negative 7 plus 5. Okay, now we can do some more complicated ones. F of, oh, let's do sad face, frowny face. Well, that would just equal frowny face, get his nose in there, plus 5. Okay, now what about f of something odd, maybe 3x minus 1? Well, that would equal quantity 3x minus 1 plus 5. Okay, what about f of x squared minus 9? Well, that would be quantity x squared minus 9. Oops, I swear I pushed the right button. Plus 5. So hopefully the color is making it better. All right. Now we're going to do something really, really strange looking. It's going to look very odd for a little bit. But what I'm doing this for is this patterning, because you literally just replace it. F of x is x plus 5, so f of x squared minus 9 is x squared minus 9 plus 5. All right, so now I'm going to come over here and do the same notation. F of x is equal to x plus 5. What would f of, oh, let's make it something fun, star be? Well, f of star would just be star plus 5, right? All right, now what about this? F of, oh, let's just make something fun, g of x. What would that give me? Well, that would just be g of x plus 5. Okay, I just do straight substitution. Well, what would f of, oh, I don't know, f of x be? It looks strange, but it's just patterning. Well, that would be f of x plus 5. And what about f of h of x? Well, that would just be h of x plus 5. All right? So that's how all of this works. Whatever I have for my notation, the f notation, that distributes over in place of the x. Every x that's on the right, it distributes over. Alrighty, so let me clear the screen and let's try this a little bit more. Here we go. Okay, for a more complicated one, let's go with something like f of x equals, let's go with x squared plus 3 times x. Okay, so let's do as an example, maybe f of 5. Okay, so that would equal 5 squared plus 3 times 5. Oops, wrong color. I messed these colored up. So that would give us 25. It's 5 squared plus 3 times 5 is 15. That would give us a total of 40. Alrighty. What about f of 0? Well, that would give us 0 squared plus 3 times 0. Well, 0 plus 0 is plain old 0. What about f of maybe negative 2? Oops. You saw nothing. Negative, I swear I pushed that button. One more time. Here we go. Negative, negative 2. I'm redoing this. I'm going to erase and start from scratch because there was too many mistakes there. So rewind. I didn't say anything. We're now ready to go to the next one. So let's try f of negative 2. Well, what would that give us? Well, that would be negative 2. Now I'm going to have to do this as a quantity because I have to include that negative sign. Negative 2 squared plus 3 times negative 2. So negative 2 squared would give me negative 2 times negative 2 is positive 4. And this would be negative 6. So 4 plus negative 6 is going to give me negative 2 as an answer. All right. Now, here we go. Let's get another layer of abstraction. So let's go with f of, let's try a star again. F of star would be star squared plus 3 times star. And I don't know what that is. I'm just going to leave that alone. All right. What about f of, 2x plus 1? Well, that would equal, this is where it gets a little tricky because just like when I had that negative 2, I had to include the negative sign, so I had to put it in parentheses. I've got two terms here, so when I substitute the whole thing, I'd better put it in parentheses before I square it because I need to square the whole thing. So that's going to equal 2x plus 1 quantity squared plus 3 times 2x plus 1. And leave it just like that. All right. Last but not least, here we go. Let's go with f of g of x. And I didn't do my g of x in color. Yay, me. I'm awesome. All right. Redo. All right. It's like doing something you can't keeping all these colors straight. So let's go with f of g of x. Okay. That is going to equal g of x quantity. So I can put it in parentheses, I can put it in brackets, it's whatever. It's all good either way. So squared plus 3 times g of x. Alrighty. So take a nice hard look at this, and hopefully it's making sense how you fill these in. You take your original definition, wherever there's an x, because this is defined as f of x, wherever there's an x in the expression on the right, I need to substitute whatever I substitute in for the x on the left. So if I put a 5 in for this x, I have to put a 5 in for all of these x's over here. If I put a star in for that x up here at the top, I need to put a star in over on the right-hand side for all the terms that had x. So when I get down to the very bottom here, I've got f of g of x. Well, that means I'm going to replace the x that was up here with g of x. So that's g of x squared plus 3 times g of x. And that's it. Okay? Alrighty, so let's take that and now let's start on composite functions. So here we go. Let me clear the screen and let's get started on that. Okay, so let's try now. F of x is equal to x plus 1, and maybe, I don't know, try a different color. G of x is equal to 3x minus 2. Okay? Now, what would f of 2 give me? Well, f of 2 would just be 2 plus 1. F of negative 7. Well, that would just be negative 7 plus 1. What about f of g, if I can erase that, f of g of x give me? Well, that's going to give me g of x plus 1. Okay? Now, here's the critical step. When I do f of g of x, I just replace the x on the right with what I defined the x on the left to be, so I replace it with g of x. But g of x actually has a value now. G of x is 3x plus 2, so I can rewrite this and just say this is equal to 3x minus 2 plus 1. All I did was a substitution between those two, because g of x has been defined as 3x plus 2. So I had g of x plus 1, that becomes 3x minus 2, which is what g of x was equal to, plus the 1. All right? Now, what about, let's go up here to this one, g of 3. Well, g of 3 would be 3 times 3 minus 2. Not going to evaluate, just write it down. What about g of 0? Well, that would just be 3 times 0 minus 2. Now, what about g of f of x? What is that going to equal? Well, that's going to equal 3 times, if I pressed it, f of x minus 2. Just filling out the pattern. G of x is 3 times x minus 2, so g of f of x is 3 times f of x minus 2. But f of x has an actual value. It's equal to x plus 1. So this is equal to 3 times x plus 1 minus 2. Okay? So this is where we're heading. This is composite functions. This is exactly what they consist of. If I have an f of x defined and a g of x defined, and I do one as a function of the other, all I have to do is substitute in directly. So g of f of x is 3 times f of x minus 2 based on my original expression. And once I've distributed and substituted this over into the expression, the last step is I actually do the substitution for what it's equal to, because this is equal. This is 100% equivalent. F of x is equal to x plus 1. So I can replace this f of x with the x plus 1. Okay, let's do a couple more examples, except with plain yellow, because this multicolor thing is driving me crazy, but I think it really drives home the point of what's going on inside the expression. Okay, so let me clear the screen and we will start again. If I can clear the screen. Okay, so let's try f of x is equal to x minus 7, and g of x is going to equal to x squared minus 3. Okay? Now, we're going to go straight in. What would f of g of x give me? Well, f of x is x minus 7, so f of g of x is going to be g of x minus 7. But what is g of x? Well, g of x is this x squared minus 3, so now I can substitute in x squared minus 3 for my g of x, and then just bring down the minus 7. Alrighty, since these two are the same, totally cool. We can do that. Now, what about g of f of x? Well, g of f of x would be, well, g of x is x squared minus 3, so g of f of x is going to be f of x squared minus 3. And so now I can substitute in what is f of x equal to? Well, f of x is equal to x minus 7, quantity squared minus 3. Alrighty, now that's how you do composite functions. This is the correct f of g of x, this is the correct g of f of x. When you're doing your substitutions, a lot of times it's easy to get them confused. What I always recommend is that you look for inside your final expression, which function was untouched. I don't have an x minus 7 in my final expression over here. What I have is x squared minus 3 minus 7. This x squared minus 3 right here corresponds to the x squared minus 3 up here. This is untouched because this is what was substituted in for the middle piece. So your middle piece is what will wind up being untouched down here at the bottom. So since it was f of g of x was the middle function, it's the of function, then it's going to appear inside my final expression untouched. And same thing over here. Over here I have, for my final expression, I've got x minus 7. Well, x minus 7 is my f of x, which means that the f of x had to be the interior piece. Okay? Let me do another quick example of that. So let's try, let me draw a line here to kind of divide things off. Let's say f of x is equal to 5x plus 2, and g of x is equal to, I don't know, maybe root x. Okay? So what would f of g of x give me? Well, that would be 5 times g of x plus 2. Well, what is g of x equal to? Well, g of x is just root x, so this becomes 5 times root x plus 2. Okay? Now, let's try over here g of f of x. Well, g of x was root x. G of f of x is going to be root f of x. Well, what is f of x? F of x is 5x plus 2. So this is going to be root 5x plus 2. And again, if you look at what is untouched, so in this case right here, I've got the root x is untouched. And root x, well, what do you know? That is g of x. The middle term, the middle function here is always untouched with the final answer. And same thing over here. The function that is untouched is the 5x plus 2. And I can see that that is my f of x up here, which means that this had to be g of f of x because the interior function is what is untouched. And that's pretty much it. All that's left now is to do a lot of practice. These things just take a lot of time to get down. Okay? So I'm going to give you some homework with this, and then we're going to hit them again the next class, and then we can move on to a different section. But I want to give at least 2 full lectures to composite functions because they are so critical. You will be doing this for forever if you keep going with math. Composite functions are just, they are something that continuously comes up. Once you hit calculus, if you go all the way to calculus, you will love that you have a solid foundation in composite functions because so much of calculus requires composite function knowledge. So let me give you some homework. Alrighty, so let's see. I'm going to clear the screen. So clear this. Okay, so let's go with homework. Let's try number 1. F of x is equal to x cubed plus 3x. What is f of, let's say, 5 equal to, and f of, here we go, star equal to, and finally, what about f of, yep, I'm going to make you do it, smiley face equal to. Okay, that seems trivial, but this is not a trivial one right here. Alrighty, so now let's move to the next one. And then for the next one, let's go ahead and say something like f of x is equal to x plus 1. G of x is equal to x squared. What is f of g of x equal to? Okay? Now for the big one. Here we go. Let's define f of x is equal to 2x squared plus 1. G of x is equal to negative 3x plus 5. I know that seems like a lot. Now, here we go. What is f of g of x equal to? And what is g of f of x equal to? Let the notation guide you. F of x is 2 times x squared plus 1. So whatever I plug in here, like this g of x, I'm just going to plug a g of x right there. That's all that's going to happen. So try these 3, and then we will pick up on tomorrow with, or Wednesday's lecture, I should say, with the continuation and conclusion of composite functions. All right, hope this goes well for you. Y'all stay safe, and I will see you Wednesday.